Okay, so a man wished to row a boat across a river to reach a point that is 25 meters downstream from his starting point. The man can row the boat at 3.2 meters per second in still water. The river is 45 meters wide and flows uniformly at 3.6 meters per second. Find two possible directions the man could steer. So we have our bank here, and what we know is that he wants to go across 45 meters. And he wants to drift down 25. So we have here is a 25 meters and 45 meters. Okay, so we're going to find the hypotenuse here. 45 squared plus 25 squared, square root of answer. And what we're going to get is 5 root 106. Okay, so basically x squared was equal to 45 squared plus 25 squared, and x ends up to the square root of 45 squared plus 25 squared, and this answer comes out to be 5 times the square root of 106. Okay, now what we're going to do next is calculate the angle. We'll call it angle B. Okay, so to calculate the angle B, what we're going to say is that tan B ends up to be 25 over 45, and B therefore is tan inverse 25 over 45. So tan inverse 25 divided by 45, and what we get is 29.05. degrees. Okay, so this here is going to be 29.05. Now what we have next is we're looking at how does he actually go about getting across the stream. Okay, so we know that the velocity of the water is something that goes in this direction here. We know that the velocity of the man has to, the actual velocity of the man has to go somewhere in here, in this direction, because this is what happens. You travel up this direction here from your start point to your end point. Okay, and then what we know is that we might want to aim this direction here and let the current take us backwards. Okay, because we know that the current is faster than the man. The man can row 3.2, but the current is 3.6. Okay, so we're going to design the velocity of man in water. Velocity of man in water is phi m minus phi w. Velocity of the man therefore is velocity of water plus velocity of man in water. We're going to start off our triangle using 2 points that start off at the same point. So what we have here is we're going to have we can start off this triangle. We can make this triangle in 2 ways. Okay, the first way we can make it is that the velocity of the man goes this way. So velocity of the man goes this way, and then we start off the velocity of the water coming this way, and then the velocity of man in water goes diagonal up and left. So that's the velocity of the man, velocity of the man in water, and this is the velocity of the water. By the same reckoning, we can do a secondary triangle, which is starting off the 2 of these at the same point. So this time around it's going to be velocity of man goes this direction here, velocity of man in water goes this direction here, and then the velocity of the water just goes directly to the right. So you can see that both triangles are actually exactly the same. It doesn't matter which way I would have done it. I'm just going to stick to one of them and apply my rules here. So what I'm looking at here is trying to figure out some angles. Okay, if that's 29.05, this angle here, the direction the man takes, is going to be 90 minus 29.05. So 90 minus 29.05, and what we get here is 60.95. So this is 60.95 here. We know that the velocity of the man in water is 3.2. We know the velocity of water is 3.6. And now we can find out what the angle X is. Okay. Now our goal is to find out the direction the man swims in the water. Okay. So we're trying to find out the angle, this angle here, angle Y. Now look what happens. We're going to do a sine rule such that sine X over 3.6 equals sine 60.95 all divided by 3.6. X therefore is sine inverse, bringing 3.6 upwards. It's going to be 3.6. Oh sorry, we used 3.6 twice. It's 3.2 for this one here. Excuse me. That's 3.2, so it's going to be 3.6 sine 60.95 all divided by 3.2. And then we're going to put that into the calculator, so we're going to go sine inverse 3.6 sine 60.95 divided by 3.2. What we get there is 79.57. Now, there's two answers to this, alright? So X equals 79.57. But there's also a secondary answer. The secondary answer is 180 minus 79.57. So 180 minus this answer gives me 100.43. So there's two answers for this triangle. Okay? So I'm going to draw two triangles now. So I'm just going to rub this out. Now what we have is that the angle X could be two possible values. It could be an obtuse angle of 100.43, or it could be an acute angle of 79.57. So let this one be the 79-degree angle, and then the next one is going to be a wider base because it's a wider angle. And what we have here this time is that this one's going to be 100.43. This is still 3.6. This is still 3.2. Velocity of the man in water, 3.2, and we still know this to be 60.95. Now, and this one here is going to have an angle of 79.57. So what we're going to do is we're going to find out what the third angle is in each case, or the angle Y. So the angle Y in both cases is going to be, for this one here, it's going to be 180 minus 100.43 minus 60.95, and we're going to get is 18.26 or 62. Okay, and remember this is the velocity of man in water angle, and then on this one it's going to be 180 minus 60.95 minus 79.57, and what we get this time is 39.48. So two different triangles. Okay. Now what this means about the two angles is that you can set off in two possible directions. Okay. So we can set off in two possible directions. The two directions we could have set off in was west, because remember the velocity of the man in water is going west and then north, so it's going to be west 39.48 degrees north. Okay, or the other one is west 18.62 degrees north. Okay, so there's your two times there. Now, in both triangles, we're now going to have to calculate the velocity of the man, which is this side here in this triangle, and this side here in this triangle. So in both of them, we have to calculate it. So in one of them, we're going to have velocity of man using the sine rule over sine 39.48 equals sine 60.95, so 3.2 over sine 60.95. And in the second triangle, it's going to be velocity of man divided by sine 18.62 equals 3.2 divided by sine 60.95. So what we get here we're going to multiply velocity of man equals 3.2 sine 39.48 all over sine 60.95. And then the second one is going to be velocity of man done in red, so 3.2 sine 18.62 all over sine 60.95. So there's two different velocity of man in both scenarios according to the different directions we took. So it's going to be 3.2 sine 39.48 all over sine 60.95. So the first velocity is going to be 2.33, and the second velocity should be a slower velocity. It's going to be 18.62, and it's going to be 1.16 or 1.17. Okay, and meters per second and meters per second. Now in this scenario, what we can see here is that you have to travel 5 root 106. So the distance, or the times, equals the distance divided by your speed. So in case 1, it's going to be 5 root 106 divided by 2.33. Let that be T1, or scenario 1. And T2 is going to be 5 root 106 divided by 1.17. And what it asks us for is the respective crossing times. So the respective crossing times therefore is 5 root 106 divided by 2.33, and what we get is 22.09. And the second one, which is 5 root 106 divided by 1.17, and we get 44. Okay, so that's our two answers for this question.